So this past Monday was the Chinese New Year Gala, and the humanoid robots had once again literally took over the stage and went viral over the internet. And also, just take a look at the massive improvements of progress from last year's show. It's hard not to be impressed. So naturally, I'm sure many of you are just wondering how exactly these robots can do these dances with Kungfu. What's the technical breakthrough that enables this? So the fundamental idea behind modern robot control is reinforcement learning, which is learning based on rewards or outcomes. And to build this brain, we first need to collect a data set of humans acting out the target motions or poses. Then you might wonder, isn't that easy? Can we just make the robot memorize or copy human motions? Not so quick. Robots cannot, because our human bodies are simply superior. We have hundreds of degrees of freedoms, not to mention muscles and flexible limbs that completely outmatch the robots. So even if robots want to simply copy, they would just fail. And of course, that's not scalable across different environments. So then what do we do to train this brain? Think about it like training a digital hindbrain for the robot whose only job is to keep the body stable and move toward a goal. So this brain is a deep learning model or neural network which takes in the robot's current body state such as joint angles, velocities, balance, and also a target pose or motion goal. And then it outputs a lot of tiny control commands to every motor in the body. And to train the model at the beginning, this brain has no idea what's doing. It sends random motor commands and the robot falls a lot. But here's the key. Even if the robot fails, we do know that something is wrong, so we can assign it a penalty. So every time the robot falls or it's unstable, we provide it a penalty, a signal. But if it matches the target pose, then we give it a reward. So reinforcement learning is essentially this simple process of trying something, measure reward or penalty, and then adjust the model slightly. And then you repeat this process millions or billions of times until the final motion is learned. But you might wonder, this seems highly inefficient, right? The robot needs to fail 1 billion times or more to learn the motion. And obviously, this certainly cannot happen in the real world. And that's right. So what actually happens is that most of the learning takes place in simulation, or a virtual world where the robot can fall safely, fast, and many of them all at once. So finally, once the model learns the motion in simulation, engineers then transfer it to the real robot. And this is what's called the sim-to-real process. And this closes the loop. So next time, when you see a robot performing complex movements, you're not watching a scripted robot, you're watching the output of a trained model that learns through trial and errors, kind of like how I learned snowboarding from many, many butt bruises.